Atom Smashers.
Hello everyone, welcome to our channel. For those who are doing MCS 300, MBM 454, and those from public health or have biostatistics, this is your video. Yeah, so today our first part of our lecture series will be discussing on the chi-square test. This is the 20 marks question, the chi-square test. Yeah, so before we delve into what is the video and we proceed with the lecture or the lesson. Yeah, just a quick reminder and a quick advice on to pull through biostatistics. So biostatistics is very easy, simple and straightforward. You don't have to overthink. Yeah, you just do with numbers. Yeah, and a little bit of understanding on how to tackle questions. Yeah, and also especially for prof, make sure that you understand you understand the definitions, the definition of each and every term. For example, you find in the PowerPoint the definitions of find the p-value or the significant level, degree of freedom, type 1 error, type 2 error, statistical power, all those definitions. Yeah, make sure that you master them. Yeah, more especially for MCQs, those measures of central tendency. Yeah, and also know how to graph the normal distribution and its characteristics. All right, so today, as I said, we are discussing on what's on the chi-square test. It's a short video, the chi-square test. So this is the question, though it has been cut here, but I'll read the top part before I begin answering the question. All right. So the question reads, as analysis was conducted to determine an association between sex and consumption of alcohol using SPSS, an investigator produced the following output. So these are the outputs which the investigator produced. The output. Yeah. So then we are told to answer the following questions: state the null hypothesis, state the assumption underlying the Pearson chi-square, comment on the validity stated and above, which test is appropriate above, what conclusion can you drive regardless the null hypothesis, give the reasons why. All right, so I'll just do a quick one. Yeah, so we'll start with, so when you're dealing with the chi-square, the exact significant, which is sig2, two sides, this one becomes the p-value or the significant level, this one. Yeah, and they always specify it's a chi-square test or a t-test or a z-test. Right, then the other things which are important is that we must focus on the table 2. Mostly focus on table 2, and we check there 2 cells, 5 minimum expected count there. These have to take note of them. All right, Then so when answering, so here they have said state the null hypothesis. So for chi-square, for chi-square's test, the null hypothesis states that there is no association between two, can use two terms or two variables, but this is just a general one. Since in the question they have specified to say they are dealing with sex and what and consumption of alcohol. So our answer will be there is no association between sex and consumption of alcohol. Consumption of alcohol, which means we have dealt with the first question to state the null hypothesis. But they can also ask you to say state the alternative hypothesis of the chi-square test. So the alternative hypothesis is just the opposite. The null hypothesis, there is no association. The alternative hypothesis, there is an association. So this states that there is an association between two terms. Okay, so for example, if they said if they asked for an alternative hypothesis about the question we're dealing with, would have said there is an association between sex and consumption of alcohol. All right, then we come to the assumptions underlying what the chi-square, which means this question we have dealt with it to 2 marks in the bag. Now we move forward to the assumptions of the chi-square test. Okay, so each test has its own assumptions, so don't mix the assumptions. So that's why I said in the beginning to say they always specify to say this test is this test is that. Here is a chi-square test. They have even specified is a chi-square test. So even in the assumptions, make sure that you put forward for a chi-square test. All right. So for chi-square test, there are about 5 assumptions. There are about 5 assumptions. So then they have given you 8 marks. So which means they're expecting you to state about 4 going up. All right. So there we'll say assumptions. So under the Pearson chi-square test, as assumptions, we have random sample, classes are mutually exclusive. Classes are mutually exclusive. Classes are independent. Then we have classes are qualitative. Then we have ideally the expected frequency should not be less than 5. So mostly you find a question which says check the validity of this validity of these assumptions. Question like that they ask. Yeah. So mostly among these assumptions, mostly there are two which we use to check for the validity of the assumptions. One is random sample and two is the expected frequency. So when you go back into the question, since the assumption of this guy said that the sample has to be random, the sample has to be what? Random. Just have to get the samples from random. Don't like you have to know this, no. Randomly. Yeah. So if people they just volunteer to say they are just volunteering, which means this assumption has been violated because we say Pearson said that you have to get some samples randomly. Then the expected frequency should not be less than 5. If the expected frequency is less than 5, that means that this assumption is what is violated. So when you get back to the question, you find that 2 cells 50% have expected count less than 5, which means according to the assumption, it says that ideally the expected frequency should not be less than what? 5. So this one is less than 5, which means the assumption has been what? Has been violated. So okay, so we move to the next question, which says comment on the validity of the stated in above B here. So which means since in the question they haven't mentioned either they got they just volunteered or they just got randomly. According to the question, they didn't specify because they just said analysis was conducted to determine an association between sex and consumption of alcohol using SPSS. An investigator produced the following output. They didn't specify if they just got any randomly or they just volunteered. So from what we have here in the question, which they have said 2 cells 50% have expected count less than 5, which means that the expected frequency is less than 5 and the assumption has been what? Has been violated. So the validity there, we say the expected frequency is less than 5, hence violated. Okay, hence violated. So if the expected frequency, this one we have dealt with it, if the expected frequency is less than 5, we don't use the Pearson's value, this one, the Pearson's value, this one, if it's violated. So hence we go for the Fisher's exact test. The Fisher's what? The Fisher's exact test. Okay, so even here they have asked you which test is appropriate for the above analysis. Give the reason why. So we'll go for D. Go for Fisher's exact test. Reason being frequency expected is less than 5. Then Here question comes again, the last one. What conclusion can you draw from the result in C? From the result in C. And from that in C above, regardless the null hypothesis. So which conclusion can you give from C here regarding the null hypothesis? Alright, so we write E here. E. So the conclusion which we can draw from the result from C regarding the null hypothesis is that there is no association between sex sex. There's no association between sex and alcohol consumption. Reason being, we'll say